Hi, in this video, we're going to learn how to solve radical equations. And you have 4 steps to solve radical equations. Step 1 is to isolate one radical on one side of the equation. So for example, this radical is isolated because it's by itself. This radical is not isolated because it's got a +6 with it. So you want to make sure you isolate it. When it says to isolate one radical on one side, if you have multiple radicals, sometimes you can't isolate them both. So just make sure at least one radical is isolated. Step 2 is to raise each side of the equation to the power equal to the index of the radical. And then simplify. For our problems, we're always going to have square roots. So the power equal to the index will always be squaring. But if I had a radical with a cubic, right? If we have the cubic root, then to undo a cubic root, you would have to cube both sides. If you had a 4th root, then you'd have to take both sides to the 4th power. So that's what it means by taking the power equal to the index, but we will only have square roots, so we'll be squaring everything. Step 3, we will only need occasionally, and in our lesson for the very last problem, it says if the equation still contains a radical term, repeat steps 1 and 2. If not, solve the equation. And then step 4, you need to check all your solutions in the original equation for extraneous solutions. A lot of times when you're solving quadratics, when you're solving linear equations, you're checking your solution just to do that, to check it. For these, this is not an optional step because sometimes you do the right process and then you get something called an extraneous solution. And it's just that. It's an extra solution that actually does not work. And so you have to check your work. So we have 7 examples, and that's the entire lesson. And we're going to be using these 4 steps. So number 1, isolate the radical. We already discussed it's isolated. So we're going to raise each side of the equation equal to the index. The opposite of taking a square root of something is to square it. When you square this, you're going to square everything. So here your square root and square cancel. You're left with what's under the radical of 3x minus 4. The whole point of squaring is to get rid of that radical, and we did. And then on the other side, 5 squared gives me 25. And now just solve like normal. We're going to add over 4. And we get 29. Then divide by 3. And we get x equals 29 over 3. Now, before I square this, box it, circle it, whatever, you have to check it for extra solutions, for extraneous solutions. When you check, you're simply plugging this in. And you're plugging it into the original. Okay, the original equation. So I'm going to have 3 times 29 over 3 minus 4. And I want to know, does that equal 5? So simplify over here. Those 3's will cancel. So I've got 29 minus 4. 29 minus 4 gives me 25. And the square root of 25 is 5. So that checks out. And so this is my solution. Number 2, isolate the radical. So to do that, we need to move this 6 over. And so we're going to subtract it. So we'll get the square root of 5x plus 4 equals -4. Now, to get rid of that square root, the opposite of square rooting is to square. So I'm going to square this entire side and this entire side. Notice I'm putting it in parentheses. So I'm squaring everything, not just the 4, but also the negative. Square root and square cancel. I'm left with what's under the radical. So I did my job. I got rid of that square root. Negative 4 in parentheses squared is 16 because that's negative 4 times negative 4. So now solve. Subtract your 4. And divide by 5. Let me get another beautiful fraction. I'm not squaring this. I'm not boxing it. I'm not circling it. I'm not highlighting it. I'm not nothinging it. Check it first. So back into the original. I've got the square root of 5 times 12 over 5 plus 4. That's all under my radical. Plus 6 outside my radical. And I want to know, does this equal a positive 2? The 5's cancel here. So I have 12 plus 4. This gives me 16. 16, the square root of 16 is 4. And I can tell from right here that this does not work. 4 plus 6 is going to give me 10, which does not equal 2. When this happens, I check over here. My algebra was good. I followed all the right steps. That means this one here has no solution. It's number 3. Okay, I've at least isolated one radical, and in this case, I've isolated them both. So now the opposite of square root is to square. So I'm going to square both sides. So square root, square cancel. We have 5x plus 3. And square root and square cancel, and I'm left with 4x plus 5. So this one turns really easy. We're going to subtract our 4x over. We get x plus 3 equals 5. Subtract 3. And x equals 2. We are not done because we need to check. So plug it into the original. We have 5 times 2 plus 3. And I want to know, does that equal 4 times 2 plus 5? This is 10 plus 3. This is 8 plus 5, which gives me the square root of 13, does equal the square root of 13. This is my answer. If you're in the companion lab, this will be covered in a future lesson, but this is the only time we need it until module 4. So you're going to have a problem that has x minus 8 to the 1/2 power. This is going to be different, but it's going to be to the 1/2 power. You can rewrite this right here as the square root of x minus 8. And then everything else is going to stay the same. Okay. So this is a rational exponent. And you can write that as a square root. All that means is that the 1 stays right here. So that's to the 1st power, and that 2 comes around, and that's why it's to the square root. So if that was 1/3, this would be the cubic root, but it's the squared term. So it is right here. We just don't write it because it's known to be there. So follow your steps. Isolate your radical. So we need to subtract our 10 over. Okay, let's keep going. So now we isolated the radical. So we're going to square both sides. You get x minus 8 because the square root and square cancel equals 9. We'll add our 8 over and x equals 17. We must check this first. Now it says to check it into the original. This is the original, just wrote in a different way. So I am going to check it into this one here. So I've got 17 minus 8 plus 10. And I am looking for, does this equal 7? So this gives me the square root of 9, which is 3. And 3 plus 10 does not equal 7. That equals 13. So this is another no solution. Now I kind of paused for a while because I didn't know if I actually wanted to go all through that. Usually when I teach this in class, I remember to talk about why this one's a no solution, and then we don't have to work through this one because we understand why. I didn't do that. And so let's talk about both of these. What did these two have in common when solving that made these no solution? Well, it's that we had a point where we had the square root of something equals a negative number. In this case, it was a -4. On this one, we have the square root of x minus 8 equals -3. When we take the square root of something, and like we're solving for quadratic formula, we always have the plus or minus. But in general, we're not looking at those negative numbers. And so when you have something of the square root of whatever you have under it, but the square root equals a negative, the square root here equals a negative, it's always going to end up being no solution. And so if you can see that from looking at that, you don't need to go through these other steps. You can just skip to no solution. If you can't see it, it's not really that big of a deal and it didn't take us that much longer. Finish the problem, check it, and you'll see that it comes to no solution. Okay, 3 more problems on the next page. All right, here my radical is isolated, so we're going to square both sides. Square root and square cancel, so I am left with 40 minus 3x equals x squared. Because I have a squared, we have a quadratic equation. Last lesson was all about quadratic equations. We got 3 ways to solve: factoring, quadratic formula, and square root property. I can't use square root property because I have a B term. So I'm either using factoring or quadratic formula, and either of those need to be in standard form. So I'm going to move my 40 and my 3x over because I want to keep my squared term positive. So I've got x squared plus 3x minus 40. Add your 3x over, subtract your 40 over. I highly recommend that you always check factoring for quadratic formula, especially if you're good at factoring, because that takes way less time. So for this, my a times c is -40. It's 1 times -40. My b term is +3. What adds up to 3 and multiplies to -40? Okay, watch your signs. That should be 8 and -5. 8 times -5 is -40, but when you add them, we get a +3. Because this is an easy trinomial, that means I can go straight into my factored form of x plus 8, x minus 5. Set both of those equal to 0. and we get x equals -8 and x equals 5. I am not squaring or boxing these yet, because before I can say that these are my answers, I have to check them. And so here, we're gonna have to check twice. When x equals -8, plug it into both of your x's here in the original. We get the square root of 40 minus 3 times -8. And I am wanting to know, does that equal -8? So we get 40 plus 24. And that's going to give me 64. And the square root of 64 does not equal -8. So that is not a solution. And really, I could tell that was not going to work from the very beginning, because I had the square root equaling a negative number, which doesn't happen. So let's check x equals 5. Same thing, plug in 5 for both x's. Okay, does this make a true statement? We get 40 minus 15. 40 minus 15 is 25, and the square root of 25 is 5. So this is my solution. Okay, on 6, we need to isolate the radical, and we'll do that by adding our 4 over. So I'm going to get x plus 4 equals the square root of 3x plus 10. We do have a lot to write on this one. I've already kind of set myself up bad with big writing here, but you might want to start writing small, because we are going to have a lot of steps right here. So heads up. I've isolated my radical, so that to get rid of the square root, the opposite operation of square root is to square. So I'm going to square both sides. Over here, x plus 4 quantity squared. This is the same as x plus 4 times x plus 4. You need a FOIL. So your first is x times x is x squared. Your outer is x times 4. Your inner is 4 times x. And your last is 4 times 4. When you combine like terms, this becomes x squared. 4 plus 4 is plus 8x plus 16. So be careful here. A lot of times we'll make the mistake of, just for lack of better words, distributing the square. But if you do x squared plus 4 squared, which is 16, you miss out on that whole middle term here. So you have to expand that out and FOIL. And then on this side, our square root and square cancel. And so I'm left with 3x plus 10. We have a quadratic again. I know it's a quadratic because I have a squared term. So we need to get everything to one side, which means I'm going to move these two things over. So I'm going to get x squared. 8x minus 3x gives me plus 5x. And 16 minus 10 is plus 6. Okay. I really set myself up bad because I don't have enough room. So hopefully you do, but I'm just going to add a little piece of paper here for me. We need to factor this. My a times c is 1 times 6. My b term is 5. What adds up to 5 and multiplies to 6? And that's going to be 2 and 3. 2 times 3 is 6, 2 plus 3 is 5. So this factors, because it's easy, because my A is 1, to x plus 2, x plus 3. I'm going to use my zero factor property, and we will do x plus 2 equals 0 and x plus 3 equals 0, which means my two solutions are x equals -2 and x equals -3. Before I can say that they are my answer, I have to check this. So when x equals -2, plug it into the original, and both x's I'm replacing with a -2. So we get -2 equals the square root of 3 times -2 plus 10 minus 4 on the outside. Do these two sides equal each other? We get -6 plus 10. This is the square root of 4. The square root of 4 is 2, and 2 minus 4 does give me -2. So this is a solution. You might say, well, the square root equal to negative, so why is it not work just like it didn't work up here? And the difference is this was just a square root. This one's a square root minus 4. So the same rule doesn't apply because this -4 can still make this negative. So be careful there. And then let's check x equals -3 in the same way. So both of these x's replace with -3. Okay. So we get -9 plus 10. This gives me 1. The square root of 1 is 1. And so yes, 1 minus 4 does give me -3. So this is also my answer. So this one here has two solutions. So with these, you have to check them because in this case, both of my answers were right. They did work when I checked them. With this one, only one worked, one did not. You can also do this and check both of them and neither of them work, and it's actually a no solution. You have to check these every single time, guys. And then our last one. This is where these steps actually come back into play, some that we haven't used. So let me get our steps right here real quick. Okay. So step 1 is to isolate one radical on one side of the equation. So this is what it means here. I've got two radicals, but I at least have one radical isolated to one side. So I can go ahead and go to step 2 and square both sides. Okay, write small on this one as well, because we got a lot of steps here. Our square root and square cancel, and so I am left with x minus 75. I'm going to bring this down here in a second, kind of like I did right here. Okay, on this side, we have to FOIL this out. And actually, let's just save some space and do this on a separate sheet right here. You cannot distribute that 2 you have to expand it out and then FOIL. So this is 15 minus the square root of x times 15 minus the square root of x. 15 times 15 is 225. 15 times the negative square root of x is negative 15 square root x. Negative square root x times 15 is negative 15 square root x. And negative square root x times negative square root x is a positive x. Combine your like terms right here. And this is 225. Negative 15 minus 15 is not 0. That's negative 30 square root x. And then plus x. So this next line, once my square root and square canceled, this is x minus 75. And then 15 minus square root x squared is this right here. 225 minus 30 square root x plus x. Okay. So back up here to these, we have not had to use the step 3. It says if the equation still contains a radical term, repeat steps 1 and 2. I still have a radical term, so I need to repeat steps 1 and 2. So step 1 is to isolate the radical. So let's get this radical here by itself. The way I can do that is by moving over my 225 and my x term to the other side. So I will subtract 225 and I will subtract my x. My x cancels here, my 225 cancels here, and my x's actually cancel here as well. So negative 75 minus 225 is negative 300. And then over here, I just have negative 30 square root x. Let's keep going to get this square root by itself. I'm going to do that. This is negative 30 times the square root of x. The opposite of that is to divide by negative 30. Negative 300 divided by negative 30 is 100, and that's going to equal the square root of x. So I have now isolated my radical. That was my second step 1. So my second step 2 is to get rid of the square root by squaring both sides. And let's back up for just half a second, sorry. Negative 300 divided by negative 30, this is supposed to be 10. Okay, negative 300 divided by negative 30 is 10. I put 100. Because now 10 squared is 100. Sorry about that. All right, before we are done, we need step 4, which is to check my solution into the original to see if I got an extraneous solution. So we get the square root of 100 minus 75 equals 15 minus the square root of 100. I replace both x's with what I think my answer is. The square root of 100 minus 75 is 25. 15 minus 100, 100 is 10. And so this does work because the square root of 25 is 5. And 5 minus 10 is also 5. So this is my answer.